Let's review a term or two from the last video and then add a couple more terms. Active reinforcing means we're applying a constant force to the concrete that helps make it stronger. This force is always in the concrete, and we do this by pre-stressing the concrete. This term, pre-stressing, refers to the fact that we're introducing a stress before the concrete is loaded by those external forces, before it has a chance to move or bend, for example. There are two ways that I can pre-stress concrete. I can post-tension it, or I can pre-tension it. Post-tensioning and pre-tensioning are both methods of pre-stressing concrete. These terms just refer to when we tension the pre-stressing steel that will squeeze the concrete. In post-tensioning, I'm going to tension the steel after the concrete's placed and gains some strength, whereas in pre-tensioning, I'm going to actually tension the steel before the concrete's placed. I'm going to hold it that way and then place the concrete around the steel. Pre-tensioned concrete is going to be a form of precast concrete. I'm going to make this concrete element at a precast plant and then haul it out to the job because I need special casting beds to build these kinds of forms, and I need big steel bulkheads to tension my pre-stressing steel against and hold that tension in the steel while the concrete's being placed. In this procedure, I build those forms on a casting bed at the plant. I run the high-strength pre-stressing steel cables or tendons through those forms and secure them in those steel bulkheads at one end. And at the other end, I use a hydraulic jack to stretch or tension that pre-stressing steel to a predetermined force. Then I'm going to anchor that force in the bulkhead, and I hold it there while I place the concrete in the forms. The concrete's going to harden and it'll bond to the pre-stressing steel. And then I can cut the steel loose from those bulkheads, which dumps all that force into the concrete, squeezing it together. So again, pre-tensioning needs to be done at a precast plant where I have the casting beds configured to hold and tension that pre-stressing steel. If I want to get pre-stressed concrete out on the project site and use more conventional formwork, for instance, that would be the same as it would be if I was just installing rebar, I need to use post-tensioning. In this technique, the pre-stressing steel is going to be housed in a duct or a sheathing that I install just like the rebar. And I'm going to thread the pre-stressing steel through an anchor at each end that will be embedded in the concrete. Once I have all that in place, I can then place the concrete and let it harden. When the concrete reaches a sufficient strength, I lock it into the anchor at one end, and I use a hydraulic jack at the other end to tension it or stretch it to a predetermined force. Then I use a set of wedges to lock it into that anchor. I now have the pre-stressing steel tensioned. The concrete's being squeezed together by the anchors, and I'm getting all the benefits of pre-stressed concrete out in the field without having to make these concrete pieces at a precast plant. Either way, I have a tremendous amount of force actively squeezing the concrete together to keep cracks from forming and to increase the bending capacity of that concrete member that's being pre-stressed. This alone can provide tremendous advantages over passive reinforcing. But let's look at one more advantage we can get out of active reinforcing. I've used the term pre-stressing steel cables or pre-stressing tendons. Now, they do make pre-stressing bars for certain applications, but most of the time, in a beam or a slab, we use special high-strength steel cables. Now, since cables are flexible, we're not limited to installing them in just a flat profile. We can bend and drape them so that the profile of the cables follows a path where the high and low points cross over those same areas that we looked at earlier where the most tensile stresses are going to occur in the concrete. That is with the high point over the supports and a low point at the midspans. Placing pre-stressing steel in this draped profile gets me several things. One, I'm placing the steel where it's going to do the most good. When I stress the cable by pulling on one end, I'm squeezing the concrete together to increase its bending strength. But also, think about what happens when I pull on this cable that now has a draped profile. It wants to straighten out. But since it's contained in the concrete, those upward and the downward forces generated as it tries to straighten out, those forces are transferred into the concrete just like the squeezing force. This actually lifts up on the concrete out in the middle where gravity's trying to pull it down. And it pushes down over the supports where the supports can take all that force and transmit it down and back into the structure's foundation that's bearing on the ground. This is a concept that designers call load balancing. We're actually using the pre-stressing steel to pick up or lift the concrete in the middle and dump all that weight into the supports. Done correctly, this allows us to get concrete to span incredible distances and have fewer supports or columns in the structure. Between squeezing the concrete together to help prevent cracks from occurring while the concrete shrinks, increasing the bending strength of the concrete element, and generating uplift to help span longer distances, pre-stressing brings a lot of advantages and makes it possible to do even more with concrete. Let's take a look at some examples.